All right, so this is going to be a U sub for a definite integral. And I'm going to use the same problem from last time, and I'm going to make it definite by just adding bounds. So 0 and 3. Boom. Great. Now it's definite. All right, so we're going to use cup. So C is what you care about. U is put everything in terms of U. And P is plug U back in at the end of the problem. So care about. What do we care about? We care about U. We care about du. We care about dx. And we care about x. Now, this variable here is always the same variable in your problem. So if it's r in your problem, this is going to be dr and then r. So we pick u. U is, you ask yourself, okay, what looks the most trickiest? This. And then you pick what's on the outside. So that's going to be r squared plus 9. Alrighty. And then du is just the derivative of this, which is 2r, and then add dr at the end. And I explained where dr comes from in the last video in the indefinite problem, so make sure you watch that if you have questions on that. Then dr is you take this and solve for dr, so that's du divided by 2r. And then r, I don't solve for ever until I go to this step. If things don't cancel out in this step, then I go back, and solving for r might help me see things in a different way. But usually, things cancel out, and if it doesn't, that means that U-sub is not the right strategy for this. In Calc 1, that's probably not going to happen because you don't know any other integration techniques, but in Calc 2, if it doesn't cancel out, then obviously U-sub might not be the best integration technique. Use the other ones that you've learned. So, or you will learn in the future, excuse me. So, in this case, now you put everything in terms of U, but that includes the bounds. So that's why I like cup, because it reminds you, wait, everything has to be in terms of U, including the bounds. Because right now, this is r is equal to 3, and this is r is equal to 0. So I go back over here, and I'm like, okay, r is equal to 0, r is equal to 3. What are those values in terms of U? Well, just plug them in here. So r is equal to 0, that's just u is equal to 9, because 0 plus 9. R is equal to 3, that's 3 squared, that's 9 plus 9, that's 18. So this becomes 9, 18, everything, the bounds are now in terms of U. So then I'm going to put 4r, this is u squared, right, because I replaced that with u, and then dr is du over 2r. And this is why I don't solve for r in the beginning, because it's easy for me to see that the r's just cancel out. And then by integration rules, this is 4 divided by 2, right? This is the same as saying 4 divided by 2. So I can bring that out to the front here. So that becomes 4 divided by 2, which is just 2. All right? And then this just becomes du. And then I can take advantage of my power rules, make this into a power. 9, 18, 2, du. And everything's in terms of u, right? Everything, this is this, but in terms of u, right? If you see any other variable, then you did something wrong, all right? Plus 1, that becomes a negative 1, so you take whatever this is, divide by it, negative 1. So this becomes u divided by negative 1, which is really just negative 1, which is really just 1 over u, which is really just negative 1 over u. And this is all being multiplied by 2, and we're adding a plus c because it's, oh, actually, my bad. That's funny. It's a definite integral, so no plus c, right? Forgot about that part. So then we can actually distribute the 2. And so what I like to do, if it's a definite integral, I like to put my little bar line, 0, no, my bad, it's 9, 18. And then I go to this part, and I'm like, okay, number 1, I have to plug in u, but this has a double meaning because you're literally plugging in u, but you're also taking into account that you're not going to plug in this u, you're going to plug in these u's because these actually are your u's. Like, it's a definite integral, so these are the u's that you need to plug in. So by the fundamental theorem of calculus, it's going to be negative 2 over 18 minus negative 2 over 9, right? This just becomes a positive, okay? And so that becomes negative 1 over 9 plus 2 over 9, which becomes same denominator, so just 2 minus 1 is 1 over 9. And that is your answer to this definite integral, okay? So that is really the part, or the difference between an indefinite and definite. Indefinite, you're plugging in this u and adding a plus c, but because we actually have the u's, we have that the u's are 18 and 9, right? We actually plug in those u's. Okay, so that's the difference, and then you just solve. and you get 1 over 9. All right, that's the difference. Make sure you put everything in terms of u, including your bounds. And instead of plugging in this u for a definite integral, you plug in these u's, okay? So hopefully that helps you out. And I'll see you in the next video.